Good afternoon.
Good afternoon, sir.
Hope my screen is visible.
Yes, sir.
Yes, then fine. So, any comments on the internal marks? Hope you all received your marks. Any doubts? Any challenges? Any issues? Any surprises? So, you're all comfortable, happy with the marks? No problem. Okay, fine. Okay, let us come back to the discussion. So, we have started the module 3, which was about loaders and linkers. We briefly discussed about various types of softwares what we have in system software category, and the second category was loaders and linkers. And we have seen the definition of loader. We looked at the various functionality of the loader, and we also touched upon two kinds of loaders. One is an absolute loader, other one is a bootstrap loader. Now today probably let us go in detail about the absolute loader and bootstrap loader. To recall once again, an absolute loader is the one which makes sure that whatever the program that we have submitted as an object program for execution will be located or loaded in the main memory at the same address that is provided as part of the object program. Meaning, if we have done a object program where 2500 is the address, then absolute loader is going to confirm that until you get 2500 as your address, which is there in the main memory, while submitted for execution, it will not load it. In other words, it will make sure that your program is loaded at the same location that is given. So we also know that a loader, of course, is supposed to load the program into the system, but we cannot have every time a loader to be absolute loader, because that is going to be a deadlock like situation. So absolute loader is a special loader. Even bootstrap loader is also a special loader. So absolute and bootstrap loader are a special category loaders which are going to serve some purpose, but they're not available for everybody. So if you write a program and you submit that program, your program cannot be taken as a absolute program, because that is not possible always. And hence, the loader that is going to load your program cannot be considered as a absolute loader. It will be called as a relocatable loader. So absolute loader is a special purpose. For example, we know that at the time of booting, operating system need to be loaded. So when you're loading operating system should be loaded at the designated location. It cannot be loaded wherever you want or wherever we want. So if that is the case, the loader, that is a bootstrap loader, that is going to load our operating system into main memory every time when you switch on the system, is an example of a absolute loader. So absolute loader has its own challenges, in the sense we cannot have absolute loader to be used for all types of programs. Not possible, and it should not be done as well practically. So however, a concept of absolute loader is one which means that the program that is submitted for execution is going to be loaded at the same location that is specified as part of the object program. So we'll see that in detail, what is the algorithm and how the memory looks like for that. Okay. So consider now a program is written like this. Let me take a better version of that. So this is the program. This is object code now. So object program is given with a header record, text records, and end record. And we know that this program, when it is submitted to the execution, the T records are the one that is going to be loaded into memory. All other records are only for the reference. The T records, what you see, that too especially from the line character number from 10 onwards, are going to be majorly utilized for the storage purpose. Meaning that the object program what we have here, in that the space what we have from this location, this side, this part is what we are going to have as part of our memory. So this portion is going to be part of our memory. All other things are only a notional information. It is header record, text record, what is the starting, what is the length. All those are not going to be part of the executable program, they are only information. So the address what is specified here as a part of the program is what is the address what we are talking about, and this is address given at the time of the assembly. Now we are in the concept of a absolute loader, where the absolute loader is going to load the program at the location that is specified in the object program. Now come back to the memory now. This is the memory now. If you look somewhere, there is address by name 1000. So at the location 1000, your data, that is 141033. You can see 141033. Next we have 482039. So 482039. Next we have 001036. So 0010, like that. In continuous memory locations, the object program is loaded. So in the whatever the sequence it is available, that is the first text record, second, third, fourth, and so on. The same sequence starting from the location 1000, we are going to store the data. Why 1000 now? Because it is a absolute loader. So absolute loader means it is going to load the program or the object program what is there for execution at the same location that is specified in the memory. So this is just an example of how absolute program is going to work for us. So if at all you look at the concept or operation of absolute program, it takes the header record. Header record is the one which talk about the name. You can see the name of the program here. That name of the program is assigned, and the address what is there here, that is 1000 will be allocated, and the number of size 107, that is 1107. All this data will be used here, and make sure that you are going to save the program. So 107A plus 1000, so 207A. So we are starting at 1000, it will go up to 207A. So this is the 207A where it is going to end. The border what is mentioned here is what the actual program object. Like this, any program that we are submitting will be given to the memory, and that resides in the memory in the continuous memory or sequential memory locations. That is an idea about the loading of a program from secondary memory to the main memory or for execution purpose. So let us see the algorithm. Okay, this is what we want, but how we can do that? So let us look at the algorithm now. This is an algorithm for a absolute loader. So absolute load algorithm is very simple and straightforward, meaning that it is very easy. We have seen 4 functionalities: memory allocation, program linking, memory allocation, program linking, program relocation, and loading. Here memory allocation is easy because whatever address you are specifying, that address should be used and it is available. And later linking, if at all any linking need to be done, it will perform. Later relocation is never arises because it is absolute program, absolute loader, and fourth one is a loading. So majorly it gives the very easier way or straightforward way of loading the program into the system. But nevertheless, let us see what is the functionality or the algorithm for a absolute loader. So absolute loader or any loader, the first record is a header record. So header record will give you the name of the program, the starting address of the program, the length of the program. So based on that, it will check the number of bytes available in the memory and the starting address. If it is available, we'll go to the first text record. So read the first text record. How long will do? Until you reach the end of the record. Until you reach the end of the record, you keep on accessing all the text records, and whatever the data what we have in the what is object program, that will be stored from the object code to the location in the memory. Okay, so we are going to move the object code directly to the specified location in the memory. So once that is done, next text record or next object program in the text record, keep on reading that until you reach the end of the program. So once that is done, you'll go back to the beginning of the program. We go back to the beginning of the program because program need to be executed. Once loading is done, we have to execute the program. So once loading is over, then we'll take the control to the beginning of the program, that is 1000 in our case, and start executing the program. That's what the idea behind this. And you see something here, if object code is character form, convert into internal representation. Time being, you don't worry about this, but assume that whatever the object code we have, that will be stored into the memory. So this is very important topic, but we'll come back to right now. Don't worry much about this, but assume that the object program is going to be loaded properly at the specified location in the memory, because we're talking about a absolute loader. So it is very important from exam point of view. They might ask you, discuss about the absolute loader. So what you have to write? What is the definition of absolute loader? And what is the functionality of, what is the operation of absolute loader? Meaning that it considers the header record, reads the memory available, starts loading the program at the whatever the memory it is assigned, and later it will take each data from a text record and stores into the whatever the memory it is supposed to be. Later you write about the small pseudo code of algorithm for the absolute loader. This is an idea behind the absolute loader. We require this because this is very simple and straightforward, and we use the concept of absolute loader in the next one called as a bootstrap loader. Okay, so next idea or next loader concept is a bootstrap loader. We know that bootstrap loader is again a special loader, which is mainly, why mainly? It is only unique purpose is to load the operating system into the memory. So we have seen in the previous class why bootstrap loader is required and what is the purpose and how it is being used. So bootstrap loader, in a step-by-step process, it loads the entire operating system at the time of switching on the system. Every time at the which you call it as a booting of a system, that the operating system will be loaded basically from secondary memory to the main memory. The one which is going to load, the special loader rather, which is going to load the operating system into main memory is going to be termed as a bootstrap loader. It is called as a special loader. Why? Because its only purpose is to load the OS into the main memory. Once that is done, it will go to the silent mode or no work for it. It will sleep. It will be active only when the system is restarted. Maybe you can restart on your own or system gets restarted for whatever the reason, but only when the system is getting restarted, during that time only the bootstrap loader is going to be active. Till then, bootstrap loader will not be active. Once it loads operating system into the system or your computer, which is happening at the time of booting, over. Bootstrap loader will never do anything. That is the reason why it is called as a special loader. And it is absolute loader. Why? Because it is going to load whom? It is going to load operating systems. Operating system is a supreme in a computer, and hence operating system should be able to, it is like a first citizen of a country. When President of India is coming, no rules will apply because he is the one, he is a main boss, he is a what is called head of the country. So he or she has to be given all the flexibility like a VVIP type of a treatment. So whatever he or she says, we have to follow. If that is the case, if operating system is like a VVIP of your computer, it is a first authority in the system, and everything will be under the control of operating system. Thereby, when OS is to be loaded, it has to be loaded at whatever specified location it has to be. If that is the case, and maybe in a designated location, we can say. If that is the case, bootstrap loader has to be absolute loader because it is loading none other than the operating system. So that is an idea. If it comes to the definition of a bootstrap loader is a special and absolute loader that loads the operating system into memory when the system is started or the booted. That is the concept of a bootstrap loader. But very important concept what we see now is the algorithm of a bootstrap loader. So before that, let us see how the bootstrap loader is going to be initiated. So operating system is available in our secondary memory now. The secondary memory data, what is holding now operating system, has to be brought to the main memory. That's what we have seen in the previous class as well, because any program, whatever may be the program for that matter, need to be brought into the main memory before it is being used or executed. So that applies to even to operating system. So during that booting time, operating system is brought into the main memory, and that becomes the first entity to be loaded into the system. Once that is done, bootstrap loader will not do anything. It will be ceased to function. It will be deactivated, we can say. It will be active only when the system is restarted. So that's the concept of a operating system. It's only unique purpose. That's what probably we can keep that in mind for the bootstrap loader. Now, so bootstrap loader, now we are looking at the SIC bootstrap loader. No doubt bootstrap loader is required for every system while loading operating system. Now since we are talking about SIC, let us see how we can write a program in SIC for a bootstrap loader so that SIC architecture can be used for writing this program. So let us assume certain things here before we get into the algorithm. The assumption here is the program what we are having for operating system or any SIC is going to have 1 second, is going to have 0000 as a starting address. So we have taken in the previous program 1000. Like that, our Ascii Bootstrap loader is stored at the location 0000. And it has to be loaded from one place to another place. That place can be a device or a secondary memory device or a CD or whatever it is. Let us assume that the device name is F1. We are going to load the data from the source. Source is what? F1. It is a device. And we are going to load, okay, no doubt the address is 0000 from the location. Absolute loader loads the operating system from the 0080, meaning that your Bootstrap loader itself is loaded at 0000 and the actual operating system has to be loaded at the 0080. So we have some program at 0000 which is going to talk about your Bootstrap loader. Later, our operating system, that is OS, need to be loaded at the 80, that is 0080. Where from it is going to be loaded? It is going to be loaded from the device called as a F1. So this loader is a absolute loader, and this is a very special loader, as we say, and hence we don't need to have a header record and end record because it is a special loader and special program, of course, and hence no header and end records will be available. It is only the program, very simple program, that is going to be part of that. Now, from F1, we need to take the data. The data is nothing but our operating system data. Where from we have to load that? We have to load from the F1 and at the location 0080. That's what we have to see. So 0000 is not the address of OS. It is the address of the Bootstrap loader. Bootstrap loader is also a program, isn't it? So program need to be also be loaded somewhere. So Bootstrap loader is available. It will be engaging in initializing, taking the data from F1. What is F1? F1 is a device where my operating system or any booting requirement software is loaded. That is some operating system. Where it is loaded? It is loaded at the location 0080. So from 0080, I need to load back into 0080 only because it is an absolute loader. So entire program of a Bootstrap of your operating system will be loaded or will be copied rather from your secondary memory or maybe some the device F1 to the location 0080. So that is the concept. Now, so let us take the algorithm. So algorithm has the two parts here. So first part is taking the data. Please be remembering this. Taking the data from the device F1 and loading that into the location 80. So after loading there, we need to convert into the character form. That's what I said in absolute program. You keep it for some time so that we can copy that. So this is how it is going to happen. So first one is how to get the character. So getting the character and storing it into the whatever the place we want. Okay. Now, assume we have got the character now. That character is, let us say, one object program, say 14, because you know that object program will be in terms of nibbles. If it is a 3 bytes, you will get 6 characters. For example, 1453. Let me show this again. So look at this. So if you take this one, let me take this one. So 30203F. This is one instruction. How many columns we have? 6 columns. 1, 2, 3, 4, 5, 6. These 6 columns, the first 30 is 1 byte, 20 is another byte, 3F is another byte. Now what we mean in the absolute program that if object code is in character form, convert into internal representation. So we know that it is a character form. So 3 is a character, 0 is a character, 2 is a character, 0 is a character, 3 is a character, F is a character. But strictly speaking, it should be what? This 30 should be 1 byte. But we are representing it as almost 2 bytes here. Similarly, here also we are representing into 2 bytes. 2 bytes. So total 6 character space is utilized, but actually it should be in the 1 character. That is 30 is a 1 character, 20 is a 1 character, 3F is a 1 character, D8 is a 1 character, 20 is a 1 character, 5D is a 1 character, means 1 byte of data we want. But 3 is a character, no, per se. If you know A, B, C, D, E, F, 0, 1, 2, 9, each one is a character. So it is in the character form now. The object code is in the character form. Now what we have to do? We have to convert that into the internal representation. What is internal representation? 3 0 now, which is occupying now 2 character space, should be converted into 1 byte. 1 byte means it should be taken not as a 30, it should be taken as a 30, it should be taken as a 20, it should be taken as a 3F, it should be taken as a D8 together, not 20 or 5D. It should be some whole number, some big number. It should be 1 byte number we have to convert. If that is the case, I need to convert them into its internal representation. So for that purpose, we need to look at the algorithm. So boot is the name of the algorithm, and it is a start. That is, as I said, the program is divided into 2 parts, and we know that the boot itself is loaded at which number? At the number 0000. So Bootstrap program is getting executed now, which is loaded at the location 0000. Now, what does it contain? The first one is a clear A. Clear A means accumulator is made 00. Now LDX. LDX is 80. Why 80? I have written in hexadecimal. Why 80? Because we know that whatever the data we have at the location 80, that need to be transferred into the main memory. So I need to have this LDX. LDX means it is a index register. Even in the programs earlier, I made LDX 0, meaning that from 0 we have to start. But here we already told that it should be from location 80. So we have loaded index with the 80. Next it becomes 81, 82, 83, 84, 80, 81, 82, 83, 84, like that. So we have initialized now with 80 because your OS is supposed to be loaded at this location. It is not that we want 80, it is already given for us. So what is given now? It should be loaded from the location 80. If it is given as 100, we will change it to 100. And please be careful, write H always, because it is a hexadecimal. Addresses are always in the hexadecimal. If you don't write H, what will happen? It becomes a 80 decimal number. Total meaning will be different. So be careful. So what is given here is a address, which is a hexadecimal number. So just for your clarity, make it as a H. Okay. Now what we are going to do now? We have identified the memory now, location. Now I need to get the character. So what I have to do now? I have to get the character. So first, I need to assume that character is given. Assume that character is given. So JSub is there. What is JSub? Jump to the subroutine. Where is getC? This is the getC. So we'll come back to this later. Don't worry now. Assume we have taken a character. So we have taken one character. What is the character here? Out of this example, let us say, out of 30203F, I have taken only 3 now. One character I have read now. But I need to take it how? 30, not 3 separately, 0 separately, but together it should be 30. Together it should be 30. That's what I want to have it now. Next. Okay. Now I have taken the character. So I have taken the character now. That character is, let us say, 3 in our example. So I have taken 3 now. So 3 is coming now. Where it is staying now? It is staying in the accumulator. So now I am moving that from accumulator to the S register. S register is what? S is a general purpose register. So from accumulator, I am storing it into S. So what S is having now? S is having 3. Value 3 is stored. Okay. Can anybody let me know what is the 8 character? I mean 8. Okay. You just write 3 in your binary form with 8 bits. Just write. I want some interaction here, because without interaction, you cannot understand this algorithm. Since we don't have Blackboard, so I want you whether you are able to understand this or not. So I need some quick inputs from your end. So I want you to write 3 as like this: 0, 0, 0, 0, 0, 0, 1, 1. So 0, 0, 0, 0, 0, 0, 1, 1. This is not 4, 1. This is 1, 1. So you can take a sheet of paper and write like this, just to understand what is the conversion, character to integer, character to internal representation. So 3 means 0011. I've just taken one example here, 30203F, whatever it is. So now one character has been copied from secondary memory, that is a device F1 to accumulator. Now I am storing that into another register by name S. So what S is containing now? 00000011. So all are comfortable with this now?
Yes, sir.
Now I want multiple answers.
Yes, sir.
Yes, sir.
If you are sleeping, I will also sleep. I can't do anything.
Yes.
Yes. Have taken the sheet and written this?
Yes, sir.
Yes, sir.
Yes. So I have S now. So please take a paper and write this 000. Why you are taking this now? I am working about this particular object code 30203F. I am just explaining you how this program works. Now currently I am here now. I have taken 3. I have loaded that into accumulator. From accumulator, it has come to S because this is what the instruction is all about. Now, what I am doing now? Shift L, S, 4. What do you mean by shift L? Have heard about shifting? Left shifting and right shifting?
Yes, sir.
Yes. So I want you to, okay, good. If I want you to convert this 00000011 using this instruction, please let me know what is output that you are going to get. So I'm going to shift to left 4 times. S, 4 means whatever the content I have in S, what do I have? I have 00000011. I want this to be shifted 4 times. So I want some answer from this. Meanwhile, let me take attendance. So go through that in your sheet. What I have taken, shift 00000011 to left side 4 times and keep the answer ready. I will ask you in 2 minutes. The contents of S register, which is 00000011 at this present time, need to be shifted left side 4 times. So after shifting left side, what is the value that you are going to have in S is what I am going to ask you. Asta?
Present, sir.
Okay. Abhinav?
Present, sir.
Aishwarya?
Present, sir.
Ambarish?
Yes, sir.
Anu?
Present, sir.
Arbaz? Arjun? Arjun? Ashok?
Present, sir.
Vinita?
Present,
Bhargavi?
Present, sir.
Present, sir.
Bhavisha? Chaitra?
Present, sir.
Chatterjee?
Present, sir.
Diksha?
Present, sir.
Deepika
Present,
LG?
sir.
Deepika MB? Murali Krishna?
Present, sir.
Gangubai?
Present, sir.
Guriya Kumari?
Present, sir.
Arshit?
Present, sir.
Junjar Singh?
Present, sir.
Kavya?
Present, sir.
Kishore Kumar Reddy?
Present, sir.
Lata?
Yes, sir.
Manisha? Manjunath?
Yes, sir.
Nayana?
Present, sir.
Nilanjan? Nishant?
Present, sir.
Pavitra?
Present, sir.
Maithili?
Present, sir.
Priyanka? Pavan Kumar? Akash?
Present, sir.
Rajeshwari? Rakesh?
Yes, sir.
Ramya? Rashmi?
Present, sir.
Ravi Shankar?
Yes, sir.
Rizwan?
Present, sir.
Vishal?
Present, sir.
Savita?
Yes, sir.
Shruti?
Present, sir.
Sneha?
Yes, sir.
Spurti,
Present, sir.
Srinidhi,
Present, sir.
Srinivas,
Present, sir.
Sunil,
Present, sir.
Vaishnavi,
Present, sir.
Vinny.
Present, sir.
Okay, fine.
Sir Arjun, sorry sir, network went off.
Okay, fine. So may I have some answers. After left shifting 0, 0, 0, 0, 0, 0, 1, 1 4 times. So what is the content of S register now?
Sir, 0011 0
One
0
second.
0
One 1 second. 1 by 0, 0,
0 1 1 1.
0, 0, 1, 1.
Sir.
Okay.
0 0 0 0.
0, 0, 0, 0. Can anybody understand how it is? This is the right answer. But how it is done? So we are going to shift left side 4 times. So when I shift first time, it will come here. Second time when I shift, it will come here. Third time when I shift, it will come here. Fourth time when I shift, it will come here. So this is what the first one. Similarly, when I shift first time, this will be here, this will be here, this will be here, and this will be here. So that's why it has come. So whichever you are shifting now, that will be replaced by zeros. So 0, 0. So you will be finally getting 0, 0, 1, 1, 0, 0, 0, 0. So what we have in S now, after left shifting, is this. Is it clear? Any doubts? This is the process of a internal conversion of the character. So I want what? Not 30, I want to have a 30. Now it is 3 separately, 0 separately. Now after this, I will have 30 together. That's what we are trying to do now. Any doubts? Any doubts now? Okay, fine. Now, we have taken one character, 3. Now what do we have now? We have another character, 0. I need to take that character also. Again, I will jump to get C. So I will go to get C. That is this particular algorithm. I will get one character that is available. Where it is available now? It is also available in the accumulator. Now it is in accumulator. So one data I have in S register. Another data I have in accumulator. So what did I get in accumulator now? 0, 0, 0, 0, 0, 0, 0, 0, because I'm getting 0, 3, 0. No, 3 is done, 0 is there, and 0 is coming to accumulator now. So accumulator contains 0, 0, 0, 0. But what is the next instruction? ADDR. That means I want to add. What type of addition it is? It is a binary. Okay, bitwise binary. So now what is that? S is here, A is here. So now I will add 0, 0, 0, 0, 0, 0, 0, 0. So this is S, this is A. Now when I add it now, I will get 0, 0, 0, 0, 1, 1, 0, 0. So where it is stored now? It is stored in the accumulator. So accumulator was having so far 0, 0, 0, 0. Now it has become 0, 0, 1, 1, 0, 0, 0, 0, which is nothing but 30. So this 30 I wanted. Now this 30 has come and resided in the accumulator. So from accumulator, now I will pass to my location. What is my location? Index register. Where is index register? This 80. So to location 80, I am going to load. So stch 0, x, because index 0, x, 1, x, 2, x, like that. So x is 80 now, 80, 0. So at location 80, I am going to load now. So next, one character we have done. That means 3, 0 put together, 1 byte data we have transferred. Now I am left with what? 2, 0. So again, what is the process? Take 2, left shift 4 times, take 0, add binary, that is a bitwise, and bring it to me. So 2, 0. Like that again, repeat. What is there? 3, take 3, left shift 4 times, take F, add bitwise, you bring that and store like this. For every, suppose I have a 200 bytes, 200 times I'm going to do this. So this program is repeated so many number of times. So once that is done, one character, I'm going to increment that, because you know this instruction TIXR. TIXR stands for incrementing and comparing. So what is it incrementing now? It is incrementing to register. What is the register now? Which register? X register. So 80 becomes 81. 80 becomes 81 becomes 82, 83, 84, 85. So you are comparing as if with the same number, because this is absolute program, nothing to worry with the increment, because you have a full freedom. We can't say you load only to this number, after this number don't load. No, whatever the number we have to follow. So there is no limit here, because operating system complete program without any risk or without any deviation need to be copied. So to avoid that, what you have, that comparison, we have given XX only. So we keep doing that. So let us see how this is going to be. So we keep comparing the same number. We'll allow that to loop. So jump. It is not a jump on less than. It is not jump on greater than. Please observe this J, because when you are comparing with some limit, it should be jump on equal or jump on less than, like that. So it is a jump. So it is a direct jump, unconditional jump. So every time you get a character, jump, repeat, 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 repeat. How long? You reach until you reach the end of the object code. That is until you reach the E. We already seen in the algorithm of absolute program, until you reach the end of the program, you keep doing that. So meaning that in this program, in this first half of the program, we have taken the character form, that is each character of the object program which is there in this is going to be considered in pairs, convert them into internal representation. How are we doing that now? We'll take each character, left shift 4 times, then add the new character, then together we'll take it as a one byte of data. That is what we are actually looking at the object code. So that is what we have done so far. Now the question is, what is this getC? How we are going to get the character? Now we know we have got the character, we have converted it, and we are storing into the main memory. So that's purpose is done. Now what we have to get now? What is the purpose of a getC and how getC is done otherwise? So any doubts here so far? How the internal conversion is happening? Any doubts? So let us see how getC is done. So getC means we have to get the character. Where is that getC character now? It is from a device. What is the device name? Device name is F1. If you look at here, input X F1. It is given that the data has to be taken. That is the data of a, data means the program of an operating system need to be taken from the device F1. You know why we have used X. We have seen in some of the examples, X stands for a device. So F1 is a device, so X is used. That's what input is. So from input device we are going to take. Now we are going to test the device. We know the TD-RD business, we are testing whether the device is free. If it is not free, we have to be keep checking that. That's what we do in the JEQ. If it is free, then we can read the data. What is the data here? We are going to read the operating system program. Whatever the program that is related to the operating system is what we are going to read now. Okay. Now I will read the data. Okay. So when I read the data, please be careful here. I am reading what type of data now? Object program data. Object program can contain what? A, B, C, D, E, F up to Z, and it can contain 0, 1, 2, 3, 9. Meaning that no doubt we have only hexadecimal characters 0 to 9, A to F. These are the only 16 characters that can be part of your object program. By mistake, some new characters have been added into object program. Possibility is there. If that is the case, while loading the program, you should be careful with that. So if that is the case, we are going to consider only those 16 characters. So this program is not going to consider the extreme cases. We assume that your object program is comprised of only these hexadecimal characters, that is 0 to 9, A to F. But in reality, In reality, there might be possibility that there may be some special characters also be part of the object program. Then we need to look at that. But right now, let us not go to that complexity. We assume that we have the all 16 characters 0 to 9 and A to F. Let me look at the ASCII code. This is ASCII code. You might have seen now, isn't it? So hexadecimal 0, 1, 2, 3. This is hexadecimal 0, 1, 2, 3, 4, 5, 6, 9. Then A, B, C, D, F. Then 1, 0, 1, 1. Again 1 A. This is how hexadecimal code is. This is hexadecimal. Continuation. This is hexadecimal. This is hexadecimal. This is hexadecimal. So corresponding ASCII character. So each one has a different name. If you come here, character 4, EOT. And let us see somewhere 1B, escape, just whichever you are familiar with. 20, space, and some special characters here. 2A, star. So if you say star, internally it is represented as a 2A in hexadecimal. Don't confuse again with decimal codes. Somewhere you might have seen decimal codes 41, 42, 43, 85, 86 and all. Don't confuse. This is hexadecimal code. We are not converted into decimal code. Now, my interest is 0 to 9 because your object program will have what? Either 0 to 9 or A to F. So 30 to 39 hexadecimal code is what my interest. Later, A to F. That is 41 to 46. There are so many characters in the ASCII, but my interest is capital A to F, 0 to 9. Why capital A to F? My hexadecimal is 0, 1 to 9, then a capital A, B, C, D, F, isn't it? If that is the case, my interest is only these things. Now, let us go back to the algorithm. Now, we are comparing with 4 here now. So first, so why are you comparing with the 4? Because whether we have reached the end of the program. Just now we have seen that now. 4 means what? End of the text. End of the text means your text records have exceeded or not. If I have completed my text records, I need not do anything further, isn't it? I already copied entire text into my main program. So number 4 stands for what? Checking end of the text. So I will compare now whether I have reached with the end of the text. If I have reached end of the text, then what should I do now? My entire text program is copied. My entire operating system is copied. Then my next business is what? Execute the operating system. To execute the operating system, what should we do? We should go to the location where my operating system has been loaded. Where it is loaded? It is loaded at the location 80. That's what we have started, isn't it? So location is 80. So at 80 location, we have loaded our program, which is our operating system. So if I have reached the end of the program, I will go to the 80 and start executing. That is one. If it is not, suppose this is not 4, I'm getting some. Now let us say my data is 30202F. I am here now. Okay, is it 4? No. So this is not 4. Now we already converted. No, we have converted here like this. Okay, we're getting characters. We're getting 3. Now when 3 is there, 3 is not equal to 4. No, so it is not ASCII value. Now I will compare now with 30. Why are you comparing with 30? Let us go back to ASCII characters. So what is there in 30 here? 0, 1, 2, 3. Why are you comparing with 30? Because I am interested in the object code, which is either 0 to 9 or A to F. Anything other than this, I have to ignore. I don't want. So I am checking whether the value is 30 or 31 or 32 or 33 or 34 up to 39. Why? Because I am interested in 0, 1, 2, 3 up to 9. So 30 to 39, I will verify. So what I am doing now? Compare with 30 up to 30. So up to 30, what do we have? Up to 30, all are waste characters. I don't want them. So compare up to 30. Suppose I have got this character, let us say. I will compare that character with 30. Is 0B is less than 30 or greater than 30? 0B is less than 30, no? So anything that is less than this, anything that is less than 30, I am going to ignore. That's what I have done. Compare 30. If it is less than, jump on less than. So it means I got some special character star. What is the value of star? So star means 2A. So 2A is less than 30. So I should ignore that because I should not have all this. I should have only 0 to 9 and A to F. Any other thing that I get apart from 4, I should ignore. 4 we have already managed. So 4 we have already taken care. Any other thing I should ignore. So jump on less than to get C. So any character that is less than 30 in hexadecimal, I should not consider. Again, start doing the same process. Same process means read the next character. Assume that it is not less than 30. It is some good number. So what is that number? It can be between 30 to 39 or it can be 41 to 46, isn't it? That's what my numbers are. So 30 to 39 or 41 to 46. 30 to 39, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10. Okay, now if it is more than 30, what I will do? I will subtract. For example, I have got, let me take one example. I have got 33 because the first number is what? 3, no? 3 means 33. So we are getting 3 here, isn't it? So my number is 3. So for 3, it is 33. So 33 minus 30. What is the value? The value is 3. So I have got 3 whose value is 33. 33 minus 30. I am subtracting 30, no? Why I am subtracting with 30? Just now we have seen now in ASCII character, anything less than 30 is not required by me. I want to start at least from 30. So I am taking 30 as my benchmark. Now I am comparing with 30, I will get 3. Now I will compare 3 with 10. Why am I comparing with 3 with 10? Because from 30, I am interested in 9 characters. So 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. How many are there? 10. Just now we have seen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 characters are there. So I am comparing with 10. So when I compare with 10, so is 3 less than 10 or greater than 10? 3 is a less than 10. So when I compare with 10, 3 is less than 10, meaning that it is a good character for me. It is a good character what I am looking at as a object code. So I will copy that. Jump on less than to return. So where when I say return, where I will go now? I am from a main function. I have come to a subroutine. When I say return, I will go to the main program. Main program is this. So I will come back to this. Okay. So like that. So now I have taken one character now. Now that is not end, no, because there are some more characters. This is not end. There are some more characters. But the problem is between 39 and 41, there are some more. How many characters are there? 1, 2, 3, 4, 5, 6, 7. So between 9 and capital A, 7 extra characters are there. How many? Please say 1, 2, 3, 4, 5, 6, 7. So these 7 also I am not interested. So like 0 to 2F we have ignored. I need to ignore from 3A to 40, which is 7 in number. So what I will do now? I will also ignore those 7. To ignore what we have done, we have subtracted, no? Now I will subtract this 7. When I subtract this 7, I will be going into these values. What are those values? Then A, B, C, D, E, F. Anything further. So up to this I am worried now. So when I get D, let us say. So 44 I have got. First I will subtract from 30. Then I will subtract from 7. Then I will get my number. So like this, I am going to get my number. So first what I have done, we have taken the character. We are checking whether we have reached the end of the program. Next, if not, we'll take whether the first 30 dummy characters are there in the program. Normally it will not be there, but anyhow, your program should be capable enough to engage with all this. Assume if it is not there, then we'll say it is a 0 to 9. Fine. Then we have to check whether it is a 0 to F or not. How to do 0 to F? Because in between there are 7 extra characters, and those extra characters also we need to highlight. So this is why it is a 7. So we subtract 7. So once everything is over, we have got our program, then we will have the copy of character. So every time when you are taking a character, this particular program is going to be repeated. So this is an idea, and other things we know. What is the byte and the end of the program. So this is how we have taken the Ascii Bootstrap loader. So two things what you have to remember here is there are 2 parts. The first part is to take the character. Second part is to convert into internal representation. So that's what the idea behind this particular program. It is easy to understand, but you require some time to go through this. So this is the process. Please go through that. If you still have any doubts, let me know. Maybe in the next class tomorrow, we'll spend some more time, or maybe we can relook at again, so that if you have any doubts, we can clarify that. So otherwise, if you have any doubts immediately, probably we can let me know. If you don't have, then we can wind up this class with the Bootstrap loader. Okay. Any doubts?